I'm Jaris, and let's talk about inner ear mechanics. Let's talk about transduction! And transduction, as in the chemical to electrical process in the inner ear to our auditory nerve. We got some parts that we need to clarify. We have the pinna, the ear canal, the eardrum, the ossicles, the eustachian tube, and the cochlea and the auditory nerve. We're going to talk about the cochlea for a second, because if you unravel the cochlea, then we have some parts there as well. We have the oval window, the round window, which is kind of funny because an oval is usually round. And then we have the basilar membrane, which is flimsy guy. And then we have the tectorial membrane. The tectorial membrane is the stiff guy. And these guys are going to come into play a little bit later, but just keep in mind that the basilar membrane is flimsy, floppy, goofy guy, and the tectorial membrane is a stiff and serious guy. Now that we got that, we can take a closer look at the oval window. The oval window, there's something there. There's part of the ossicle called the stapes, and it's this I think it's the smallest bone in our body, if I'm not mistaken. I don't know. But yeah, like we have the stapes, and that's helping to push fluid throughout the cochlea. Because the cochlea is filled with fluid. Now we have these waves. Whenever we hear something, the vibration is going from our eardrum, moving the ossicles, and the stapes part of the ossicle is connected to the oval window, and that's pushing fluid inside the cochlea. And now, because all this fluid's moving, the membranes are also moving, one more than the other. The other being basilar membrane. And the basilar membrane actually has a best friend called the hair cell. And the hair cell sits in between the two membranes and on top of the basilar membrane. I always imagine it as hands. Each of the fingers are called stereocilia. At each tip, there's an ion channel, and these ion channels are mechanically gated. And I thought that was cool because that means there's something moving there. These hair cells have little fibers called tip links. So at the peak of the wave, hair cells are pushed into the tectorial membrane. This causes potassium ions to flow into the hair cell, and that causes the polarity to increase. The hair cells have a resting polarity of negative 80 millivolts, and now that there's potassium flowing in, which is positive, it increases the polarity to a positive 30 millivolts. Now that this polarity has changed, the ion channel on the bottom of the hair cell, these are voltage gated. These ion channels open, and it allows chlorine to flow into the hair cell, lowering it back to its resting rate. The hair cell then releases a transmitter called glutamate into the spiral ganglion, and then it sends an electrical signal. So the spiral ganglion turns the glutamate, which is a chemical, into an electrical signal, and that is called transduction. This was all so that the chemical could turn into an electrical signal, and that signal, is being sent through all of these spiral ganglia. They're in this bundle, and that bundle is the auditory nerve. Yeah, so that's it. That's transduction in our hearing. Now we're done. Yay! I'm not an expert on the subject, but I thought this is cool. I think this is cool stuff. It's cool to know how things work, okay?